on, Wilson. Y equals negative cosine of pi over 3 theta? Should I graph that? Okay, buddy. Okay, but wait a second. We don't even know our transformations yet. Let's look at that. Okay, so a negative outside of my cosine function is going to reflect my cosine graph over the horizontal axis. Well, it's only a negative sign. I don't have a stretch or compression out there, so I know my amplitude's still 1. Okay, so then inside my cosine function next to theta, I have my pi over 3. Well, we know inside is horizontal stretches or compressions. Pi over 3, well, we do the reciprocal, so it's really 3 over pi. Well, pi is 3.14, so 3 over 3.14 is technically less than 1. So here, we're going to have a horizontal compression by a factor of 3 over pi. So that means my period originally was 2 pi, but now I'm multiplying it because it's a factor of 3 over pi. My pi's will divide out, and I get 6. 6. That's a really nice number. So let me go to my axes and tick mark. Okay, so we always want to label our theta axis with our period, and then our y-axis with our amplitude. So let me get my 6. All right, so I have my period of 6 on my theta axis. Half of 6 is 3. Half of 3 would be 1.5. Well, this is 1, this is 2, so 1.5 is going to be right here. Okay, so if I have 5 pattern points, I'm going to need to have, 1.5 plus 1.5 is 3, plus 1.5 again would be 4.5, and then plus 1.5 again would be 6. So we didn't need these other ticks here. All right, so Wilson, you're in the wrong spot. This is cosine, so normally I start at 1, but since I'm reflecting, I'm gonna start at -1. So I already have that point, then I go to 0. Then I go high to 1. Then I go back to 0. Then I go low. So at 6 radiuses, I am down at -1. So I have my cosine pattern points this time upside down, so they kind of look like a bell instead of a cup. Boom! Cosine. Okay, so we have negative cosine of pi over 3 theta. We started at -1. We got our concave up, concave down, concave up.
What? Wilson, what's this? You finally got around to graphing something on your own? Great, what's the equation? Excuse me? Fine, I'll figure it out. Well, let's see. I am pretty sure it's cosine because it's shaped like a cup. You're starting up. And I noticed that it's 1, 2, 3. You're up at +3 and down at -3, so the amplitude is half the height, which would then be 6. Half of 6 is 3. So the amplitude is 3. That wasn't too bad. What about the period? Well, 1 full cycle occurs between 0 and pi. So I know the period is pi. See, I'm doing pretty good. What do you mean? How many cycles between 0 and 2 pi? Oh, yeah, I need that for my equation because that's b. So I need the number of cycles between 0 and 2 pi. Well, if 1 cycle is between 0 and pi, it's not that hard. There's 2 cycles between 0 and 2 pi. So b is 2. But what if it was harder than that? What would I do? So the normal period is 2 pi, and my new period is pi. So to find out b, or the number of cycles, I could just take the original period of 2 pi and divide by my new period. So 2 pi divided by pi equals 2. Okay, Wilson, think I got the equation. Y equals 3, because I'm vertically stretched by a factor of 3, cosine, b was 2, theta. sine 2 theta. Does that make sense? I think so. Because remember, we always do the reciprocal. So it's 1/2, so it's been horizontally compressed by a factor of 1/2. And 2 pi, our original period, times 1/2 is pi. And that's our period. There you go, Wilson.
Okay, last example. Y equals cosine of pi theta. So we need the amplitude, we need the period, and then we got to get our axes ticked and a graph. So pause, see how far you can get. All right, so we know the amplitude's 1. We know B is the pi next to theta. And since we have pi, we're trying to figure out, okay, that would be 1 over pi, because that's a reciprocal for the horizontal compression. So then if I'm compressing by a factor of 1 over pi, then I'd multiply the period, the normal period, 2 pi, times 1 over pi, divide out my pi's, and get 2 for my period. So then I hop over to my graph, label my period at the end, 2. Half of 2 would be 1. Half of 1 is 1/2. Cosine is shaped like a cup, so we start up. So high, 0, low, 0, high. So let's go ahead and connect our pattern points. It keeps going. It keeps going. Cosine of pi theta. Oh, Wilson!
Okay, let's go ahead and see what we can answer from our equations now. The domain. Remember, these are periodic functions and they go on indefinitely in both directions. So domain is all real numbers, or in interval notation, negative infinity. Okay, bye Wilson, I got this, that's fine. To infinity. Now, range. Well, range is going to correspond to amplitude. Our amplitude is 1. And therefore, our range goes from -1 to 1. In interval notation, it goes from -1 to 1, brackets, because it equals -1 and 1. Now we get to period. Remember, our period is the original period times the horizontal dilation, whether it's a horizontal stretch or compression. B, the number of cycles between 0 and 2 pi, is pi. So the reciprocal is 1 over pi. I have a horizontal compression by 1 over pi. And our period is 2. Now, I want you to show your skills.
Let's see how you did. Domain is all reals. Range is -5/6 to 5/6 inclusive. Amplitude is 5 over 6. The period is pi because 2 pi times the reciprocal of b, 1/2, is pi. Y equals 7 sine of theta. The domain is all reals. The range is -7 to 7 inclusive. Amplitude is 7. And the period is 2 pi because b is 1.
My gosh, that was a weird dream.